Wow, a 58 kilogram person is rock climbing when he loses his grip and falls. He hits the end of the rope going 15.3 meters per second straight down and is stopped by the rope. Okay, so we've got initial velocity, final velocity, and a vertical distance of 4.20, right? So what is the average tension in the rope as it stops him? I think we got a suvat first. Let's just find the acceleration. Okay, so this guy's falling. Right, they're falling, right? And the rope stops them, right? So they've got the 15.3 meters per second right here, and the rope stops them in 4.20 meters, right? Okay. So I think our displacement from here to here is down 4.2. Whoa. What did I just do? Negative 4.2 meters. Okay. Negative because he moves down as he stops, right? I think his initial velocity is negative 15.3. I think his final is 0. That's not very controversial, right? And then we want to find acceleration. We don't care about time. So our friend is v squared is u squared plus 2as. So 0 squared is negative 15.3 squared plus 2 times a times negative 4.2. Okay, so let's see. We've got, okay, we pull this on this side, it becomes negative, right? So, and then we divide by 2, divide by negative 4.2. And we actually get the acceleration is positive 27.86868, we'll just say, meters per second squared, right? So remember, if you stop moving down, you actually should accelerate up, okay? So this will be important. The tension in the rope will be bigger than his weight because he's accelerating up at nearly 3 Gs, okay? So now we've got the second part of the problem is we need to analyze the forces acting on this guy, right? As he stops, the force up is the tension in the rope. Gravity still is acting on him down, right? Okay, so our the weight, this force downward, right, is equal to m times g, so it's 58 times 9.81. 58 times 9.81. 568.98. So that's the force acting down. Okay, that's going to be negative. This force here, we're just going to say is positive. You always guess positive, even if you know it's negative, you guess positive. This one will be positive, though, right? This is the force down. That's the weight. That's our m times g, right? Okay, and now we're all set. We go boop, and we go unknown force minus weight equals 58 times this crazy answer here, positive 27.868. Ta-da. Okay, so that guy plus 58 times my acceleration, and I'm getting 2185.3 newtons. We're required by law to round it to 3 places, so it would be 2190 newtons.
See you tomorrow, Mr. Murray.
I'll see you tomorrow, Mr. Duggan.
Yeah, thank you again.